Hello, good morning, ladies and gentlemen. Thank you for clicking this video. First, let me introduce myself. My name is William Doloksaribu. Right now, I'm studying at Faculty of Medicine and Health Education from University of Bengkulu. Now, I will present you the medical article journal that published in 2021 named Wound Healing Potential of Cucurbita moschata Duchesne fruit peel extract in a rat model of excision wound repair. The first one is introduction. As the largest organ in human, skin covers the external surface of the body, serving as a protective barrier against different types of damage. Skin is a multi-layer organ that is directly subject to various harmful microbial, mechanical, thermal, and chemical influences causing skin wounds, so the author interested to try fasten the healing of the wound using traditional medicines. There's a lot of traditional based medicine that offer cost-effective and simple alternatives for different types of wounds like burn wounds and infected wounds, such as pumpkin. Cucurbita moschata Duchesne, or what we call pumpkin, belongs to the genus Cucurbita and the family Cucurbitae. Pumpkin is a nutritionally rich fruit. Also, its peel contains various amino acids, including aspartic acid, glutamic acid, arginine, histidine, and more. Based on that, we can know that pumpkin is a medical plant which have good pharmacological effects such as antioxidant, antidiabetic, hepatoprotective, and anti-cancer effects. So, in this research, the authors aim to investigate and evaluate wound healing activity of pumpkin fruit peel in a rat model of excision wound repair. For materials and methods, the authors use chemicals. The chemicals used in the study are ethanol and glycerin. Also, ketamine hydrochloride, hematoxylin and eosin, and EDD, sulfanilamide, and phosphoric acid. There is also phenytoin cream and cold cream. As defined, cold cream is a water in oil emulsification usually produced from beeswax and several fragrances. All other chemicals were highest grade. For plant, the pumpkin was peeled and air-dried at room temperature. Then, using a mechanical grinder, air-dried peels were pulverized to make a powder. Extraction was carried at room temperature in a percolator. The final extract was concentrated using a rotatory evaporator at room temperature to obtain a viscous liquid. The concentrated liquid was lyophilized to get a dry powder extract designed as pumpkin peel extracts, or what we call PPEs. For cream preparation, the authors used two types of formulations with different concentration of PPE, which is 10% and 20%. The PPE is prepared in cold cream-based formulation. The cold cream-based formulation was stored in the refrigerator and were first kept at room temperature for half an hour before being used for wound treatment. The authors also used cold cream and phenytoin 1% cream as different variables. Animals that used are wheat-starved rats weighing between 220 and 250 grams were used in this study. The rats were individually one rat per cage, housed under standard environment condition with 23 degrees Celsius and light dark cycles of 12 hours per 12 hours and fed with normal laboratory food and water. For creation of excision wound, the rats were anesthetized by intraperitoneal injection of ketamine or silazine. The back of the rats was cleaned and shaved using a 2.5 centimeter times 2.5 centimeters coin. Dorsal part was marked, and then excision wound was created by removing a patch of skin. Wound contraction was screened by taking photograph using a digital camera at an equal distance from the wounds and right angle to their surface. The wound closure rate was expressed as the percentage of decrease in the initial wound size. The wound closure percentage of each time point was calculated using some formula. For treatment protocol, the animals were randomly divided into 4 groups, which is 6 rats in each group. First, a treatment group receiving 10% of PPE cream, then a treatment group receiving 20% of PPE cream, and then a positive control group receiving a phenytoin cream, and a negative control group receiving a cold cream. The day of wound creation was assumed as 0, and then treatment procedure start 24 hours after full wound creation. Formulation were applied to cover the wound surface every 12 hours for 14 days. The animals were sacrificed on day 14. On day 14, before sacrifice, blood samples were taken from animals to assess serum levels of nitrate as a circulating biomarker of oxidative stress. Now we have the results here. As you can see, this is the macroscopic image of wound healing with cold cream phenytoin treated, extract 10% and extract 20%. The first row is cold cream, second row is phenytoin, and then next to phenytoin is PPE 10%, and then the last is PPE 20%. The analysis showed 10% and 20% PPE could significantly decrease the wound size as compared to the negative control group starting from day 3 after surgery. Also, wound healing activity of 20% cream was significantly higher than 10% PPE cream and phenytoin at all time intervals evaluated. You can see that this is the wound closure percentage on the paper. On the final day of evaluation, which is day 14, even though 10% PPE is a little bit left behind, 10% PPE still showed comparable effect on the wound closure rate with phenytoin. So now, discussion. Wound healing in a shorter time and with less side effects is the major aims of the current medicines. Various strategies have been made in this regard, including chemical and medicinal remedies and physical approaches such as laser therapy, with the main goals of the wound treatment is being effective, less toxic, and low-cost healing of the wound within a period as short as possible. Medicinal plants could exert wound healing effects due to their wide variety of different constituents and phytochemicals such as alkaloids, flavonoids, fatty acids, terpenoids, and more that are capable of improving the healing process. In this study, we showed wound healing activity of the hydroalcoholic extract of Cucurbita moschata Duchesne fruit peel aka pumpkin peel in a rat model excision wound repair. Also, we demonstrated the antioxidant potential of the pumpkin hydroalcoholic extract by nitrate assay. Based on wound closure result, 10% and 20% PPE cream could accelerate the process of wound healing as compared to the negative control. Also, 20% PPE cream exhibited more potent effect than 10% PPE. In a mechanistic point of view, the wound healing activity of pumpkin peel extract could be attributed to its high mucilage content and the presence of different constituents such as flavonoids and phenolic compounds that are able to accelerate wound healing as well as its antioxidant power. Also, as a mechanism of action, we show the antioxidant capability of the hydroalcoholic extract of pumpkin as reflected by reduction in nitrate levels in serum samples of the treated rats. The data shed more light on the wound healing activity of peel extract of pumpkin. Conclusion. Given the obtained data from our study, the hydroalcoholic extract of Cucurbita moschata dused fruit peel is proposed to be effective in accelerating the process of excision wound repair, partly due to its antioxidant effect in terms of decreasing nitrate concentration. So, I guess it's the end of my presentation. Thank you for your attention. Goodbye.